Hello and welcome back. Today we're going to be reviewing our unit D1, which was where we learned how to work with one variable data. In this unit, we learned to identify situations that involve one variable data, and we considered we need privacy, we need ethics, we need honest responses, and we need to consider different types of bias. We also collected one variable data from all sorts of sources, and we learned how to organize and store it using all sorts of tools, especially spreadsheets. We can now explain what is the distinction between a population and a sample. What makes a good sample, and why do we need to take a sample in the first place? We learned different ways to take really good samples, including systematic, stratified, voluntary response, all sorts of different techniques. And then we collected one variable data from primary sources using those techniques. We then organized and stored that data, and then depending on what type of data we got, we learned what the different types are. We learned how to represent that data with the appropriate chart. We also identified properties associated with common distributions of data: normal, bimodal, skewed. We used measures of central tendency and measures of spread to calculate, and we calculated those, and we interpreted what do they mean when a data set has a certain measure of central tendency or a certain standard deviation. We explained when is the best use of a certain measure of central tendency and when is the best use of spread. We also compared two or more different data sets of one variable data, and we compared those using the measures of central tendency and the measure of spread. We compared the mean of two different data sets, the standard deviation, the spread, all sorts of things. And finally, we learned how to solve problems by taking that data, interpreting it, and analyzing it if we get it from a secondary source, not necessarily data that we've collected ourselves. So in all, this unit taught us how to solve problems involving one variable data by collecting it, organizing it, analyzing it, and finally evaluating it. One variable data, we learned, can come in three different types. There's categorical, there's discrete, and there's continuous. You should always choose the chart that best fits the type of data to make your analysis of that data easier. Once your graph is complete, you can always check its distribution if it's a histogram or even if it's a column chart. There's normal distributions that sort of look like this. They're symmetrical around the mean. There's skewed distributions, which look sort of like this, where the data values, they trail off more sharply on one side than on the other. So it's almost like the data is leaning onto one side. And there's bimodal distributions, which actually has two different peaks. Bi meaning two, and modal, I don't know what that means, but that means that there's two different peaks in this distribution. We also learned in this lesson that we can use spreadsheet software like Google Sheets or Microsoft Excel to create tables and charts really easily. We then learned about standard deviation. We learned that there are three different ways to measure central tendency: mean, median, and mode, and exactly what is the best situation to use each of these three things. We also learned there are two different ways we measure spread. There's the range that tells you how far apart the extremes in the data set are, and the standard deviation, which we use the Greek letter sigma to denote. That tells you the limits that have 68% of the data in it, 95% of the data, and 99% of the data. To calculate standard deviation, we subtract every data point, which we call x, from the mean, which we call x bar. Each of these answers, we will square them to make them positive. We will find the mean of these squared differences. We call this actually the variance. Sigma squared is called the variance. If we're taking a sample and not a population, then instead of dividing by how many of these there are, the way we find the mean, you remember, is we add them all up and we divide by how many there are. But if we're using a sample, we'll divide by one less, just to make our standard deviation a little bit more spread out. Once we have that number, that variance, we will square root it to get the standard deviation. This sigma means standard deviation. And that is the amount of one standard deviation. We would subtract this from the mean of the data set to find the lower limit, and we can add it to find the upper limit. So we would create a range of data where the data would fall within 68% of it, or 68% of the data would fall within that, or within 2 standard deviations. If we do this twice, 95% of the data will stay within it. Let's look at an example of that. So this is a data set of 10 D1.N, so 10-sided dice, 10 of them. If we roll them and we add them up, this is what we get, 52. If we try it one more time, maybe we got 56. So we did this 12 times. What is the standard deviation here? And what does it actually mean? Let's interpret it. Well, if we add all of these up and we divide it by 12, we're looking for x bar, the mean of this data. And I find out that that is 51. So I've written 51 down in this column. The next step to calculating standard deviation is to subtract these two numbers. So 52 minus 51 is 1. 56 minus 51 is 5. Then we take these numbers and we square it. 1 times 1 is 1. 5 times 5 is 25. Negative 6 times negative 6 is 36, and so on. And then we take all of these numbers and we find out what is their mean. What is the average? And we get 53.16. If this was a sample, if instead I had rolled these dice 120 times and I'm only looking at 12 of the rolls, then I wouldn't divide by 12. I would divide by 11. This, what we've calculated, the average squared difference, is the variance. And if I want to find out what the standard deviation is, well, all I have to do is square root the variance to get rid of the square. But if I'm doing that to one side, I have to do it to the other side of the equation as well. And so the standard deviation in this case would be about 7.291548. And there's more decimals after here for sure. An easier way to do this would just be to use a spreadsheet. If I just put in all of my numbers into a spreadsheet, and then I use the formula STDevP, and I selected inside the brackets, I selected all of these cells, and I pressed enter, it would tell me the exact same number that I have here, 7.291548, etc., etc. See how much faster this was? Spreadsheets are really, really useful for this reason. There's another formula, SDEVA, which actually takes the standard deviation, assuming that this is a sample. So it'll automatically divide it by 11 instead of 12. In this case, what does this mean? Even though we know what the standard deviation is, what does it mean? Let's take our average, our mean, which is 51 of our data set, and let's look at the lower limit and the upper limit. So if this was all of our data, if it was normally distributed, and the mean was 51, the upper limit would be about 58, and the lower limit would be about 44. How did I get this? I took the mean and I subtracted one standard deviation, or I took the mean and I added one standard deviation. What does this mean? It means that 68% of my rolls were going to be between 44 and 58. 44 and 58. If I did this one more time, 95% of my rolls would be within 2 standard deviations. So whatever number would be over here and over here, that's 2 standard deviations. From then, we learned about populations and samples. A population is a group of people, objects, or whatever that you want to study, to collect data on. And a sample is a subgroup, a group that within that population, and a good sample would actually represent, it has very similar characteristics to the population. A sample represents all of the population, but to do so, it actually has to have the same sort of characteristics, right? We use these samples and we do something called extrapolate. We make predictions about the population based on the sample. And we do this when we're unable to collect data on the entire population itself. If I wanted to survey all these students in my class, that would be a population. And I think I'd be able to access that pretty easily. But if I wanted to study all the students in my school, that's a lot harder to do. And instead, I might take a sample, maybe one grade 9 class, one grade 10, one grade 11, and one grade 12. And that way, I have some people that represent the population of my study. Some of the sampling techniques we learned about are listed here: simple random, systematic, stratified, cluster, voluntary response, and convenience. You can always use Google Forms or other survey apps to collect that primary data. Primary data is data that you collect yourself, and it's better than doing this by hand because it will automatically put that data into a spreadsheet for you. And then you can use the data in the spreadsheet to instantly make charts and calculate standard deviations. After this, we learned about ethics, privacy, honesty, and bias. When we're collecting data, we have to make sure that we are doing it ethically. Any data that we collect should not be shared with everybody saying like, oh, this is who I got this answer from, this is who I got this answer from. It should be shared in aggregate, which means that you're only sharing the total results of the data, nothing that can be used to personally identify one person who answered your survey. Maintaining that privacy of your respondents is so important because then your respondents will be like, okay, if nobody finds out I said this, at least I can answer honestly, right? If they can't honestly answer our question, then we cannot even trust our answers. The data will be biased. We want to make sure that our methodology, our tactics, whatever we're doing to collect this data is free of bias. We learned 4 different types of bias. Sampling bias, when the sample doesn't represent the population. Response bias, when the people answering will give you a different answer based on, whether they think that's what you want, or an answer that is not honest. Non-response bias, when the answers from your survey are going to be very different from the people who chose not to answer your survey. And finally, measurement bias, where there's something wrong with your methodology. Maybe you didn't allow for those who wanted to answer honestly to actually answer honestly, or there's some way that you're collecting your data that is messed up and is going to give you fake results. The first time I encountered measurement bias is when I was actually, much younger. I was reading a book, Jurassic Park by Michael Crichton. And in Jurassic Park, they used this system to keep track of all the dinosaurs on the island. And I see a spreadsheet on their computer. And they're like, okay, there were supposed to be 19 velociraptors. There's 19. But the way they were tracking the velociraptors or whatever dinosaurs was flawed. They said there was always going to be a maximum of 19. They didn't think that the dinosaurs could reproduce. And so even though there were many, many more than 19, they stopped counting once they hit 19. The computer would stop counting. And so therefore, that was the first time I saw measurement bias. If you're collecting data on something to try and understand it, you have to make sure that there is no bias at all involved in it. Finally, we learned how to analyze one variable data, especially from secondary sources. So if you find data on a website, you could just take that entire table and copy and paste it into your own spreadsheet. Or you can even just download a file called CSV, comma separated values, and open it using Microsoft Excel. Once you have all that data that's super easy to get, then you can use formulas like the standard deviation formula or the average or even the median formula to calculate your measures of central tendency and spread very quickly. If your data has a normal distribution, then if your measures of central tendency are high and your spread is really low, that means that the population scores consistently high numbers, and so on. So if your spread is really low, that means that the data is consistent. If the spread is really high, that means the data is not consistent. If the central tendency is high, that means that your the sample or whatever you are measuring, the sample scored really high on it, and if it's low, then they scored really low. Now, high or low, depending on the context, high might be a good thing or it might be a bad thing, right? How much time did it take you to run a marathon? You don't want people who are running, who are scoring really high. That means you're taking a lot of time. A good marathon runner would score low. So, the context does matter here, but when it comes to spread, you're checking whether or not the data is consistent. A low spread means that the data is consistent.
If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.